morning all of you. I am Tanushree from Civil Engineering branch. So in the last class, we just initiated a numerical regarding your principal stress and principal strain system. So here the question is a steel bar with diameter D, which given as 14 mm, is subjected to a tensile load which is given as 10 kilonewton, which you can see in this figure, and you have to determine the maximum normal stress and maximum shear stress. That means we have to determine sigma max and tau max. So here you can see that it is a simple problem and it is not belongs to any axis kind of problem. Okay, it is a normal object which is subjected to two tensile loading system. Okay, so you just find out the maximum normal stress, which here denoted as sigma max, as only the sigma value. So sigma is the stress, and stress means internal resisting force per unit area. So here P is given, that is your internal resisting force is given, and area you have to determine by calculating the diameter of the circular system as pi by 4 d square value, and you just put this formula like P by A. P is your 10 kilonewton and you have to determine the A value like pi by 4 into diameter square. By calculating this whole calculation, you will get 64.9 megapascal as maximum normal stress value. In this way, while calculating the maximum shear stress, you just have to put the formula sigma max, which is your maximum normal stress, divided by 2, by which you can get the value of maximum shear stress value. So your sigma max equal to 64.9 megapascal divided by 2, by which you can get the answer 32.45 megapascal. So in this way you complete this total question as sigma max, which is your maximum normal stress value, and tau max, which is your maximum shear stress value of this section. So next question is, it is about a uniaxial stress system. Uniaxial means the stress is applied only one axis. Okay, so what is the question? So your question is, a metal block of 100 mm square cross-sectional area carries an axial tensile load of 10 kilonewton for a plane inclined at 30 degree with the direction of applied load. Calculate normal stress, shear stress and maximum shear stress. So here the degree is provided. This degree is not the theta value. Your theta value is always the angle between oblique plane and the vertical axis, or the maximum or the major principal plane. Okay, this vertical axis also known as major principal plane. So this angle is your theta, but here it is written that the plane inclined at 30 degree with direction of applied load. So the direction of applied load is this way. Okay, that means the parallel line. Okay, so the angle is given which is from the parallel line to the oblique plane. That is this angle. This angle is given as your 30 degree, but we need this angle. So you know that from this to this is your 90 degree because it is perpendicular to the parallel line. So the total angle is 90 degree, and in the question only this much is given. which is 30 degree. So we can find out this angle because total is 90 and this angle is 30 degree. So 90 minus 30 is your 60. So theta value is actually 60 degree. Okay. So for the uniaxial condition, the formula of the normal stress or the sigma L is equal to P by A cos square theta. So you know the P value, you know the A value which is directly given in the question, and you know the value of theta. Just put all the value over here and after that you can get the normal stress value. One thing you have to remember, while you calculate the normal stress value, you have to be careful for the units. Units always be same. So you can see the 100, which is the value of area, is given in mm square and the tensile loading system is given in kilonewton. So due to the area is in mm, so you have to convert the loading system in Newton. Okay. If it is given as meter square, then it is okay. That kilonewton is, we can provide kilonewton. But due to it is mm square, so you have to convert the kilonewton into Newton. So we know that 1 kilonewton equal to 1000 Newton. So you can see in the solution part, here given that 10 into 10 to the power 3 Newton. Okay. Then divided by A, which is given as 100 mm square, multiply by cos square theta. Theta is your 60 degree, which we will calculate here. Then by calculating the total value, we will get the value of 25 megapascal. Okay. Then come to the shear stress. So shear stress formula is P by 2A sin 2 theta. So P is your 10 into 10 to the power 3 Newton and 2 into A is given as 100 mm square and theta is your 60. So 2 theta is your 2 into 60, which is 120 degree. So by calculating the whole formula, we will get 43.3 MPa. And last one is your maximum shear stress. So maximum shear stress means tau max. So tau max value is P by 2A. So here we just put the value of P, which is 10 into 10 to the power 3 Newton divided by 2A. So 2 into A is your 100 mm square. So by calculating this whole formula, we will get 50 megapascal. Okay. In this way, this question is completed. So this is example of uniaxial stress condition. Okay. So this one is your another problem belongs to uniaxial stress system. So here also it is given as the area value of 500 mm square. Okay, and it is axially loaded with tensile force 50 kilonewton and the element which makes 30 degree inclination with the vertical plane. If the vertical plane is given and the angle is given with respect to vertical plane, that means directly theta value is given. If not, then you have to deduct 90 minus the particular angle value, then you will get the value of theta. Okay. But here only one thing is there. This object is connected to a fixed support. So here the stresses you have to determine, normal stress and tangential stress you have to determine. Also you have to determine the complementary stress also. Okay. So as the previous question we solved, in that way this question also we will solve. And another thing is complementary stress. For the complementary stress you have to add 30 degree with 90 degree. That means the theta value is 120 degree. So we will discuss this problem in the next class. So today this much. Thank you so much.